For centuries, humanities have looked to the stars, charting our cosmic home. We know of the eight magnificent planets orbiting our sun. But what if everything we thought we knew was wrong? What if, out there in the frigid, desolate darkness beyond the Neptune, a colossal hidden world has been silently orbiting for billions of years, a ghost planet pulling the strings of our solar system? And what if astronomers just found it? For decades, the idea of the ninth planet, often dubbed as Planet X or Planet 9, has been tantalizing whisper in the scientific community. It's not just the science fiction. It is the gravitational ghost story born from inexplicable anomalies in the outer solar system. We have seen dwarf planets and icy bodies in the Kuiper belt acting strangely. Their orbits are tilted and clustered in ways that defies pure chance. Imagine a massive unseen hand tugging at these distant worlds, forcing them into a bizarre alignment. What kind of objects could wield such influence? It had to be a huge planet or huge body, not just a dwarf planet like Pluto, but something many times the mass of Earth. The math pioneered by the brilliant minds like Mike Brown and Konstantin Batygin at Caltech has been screaming for this missing world. Their model predicted a super Earth or a mini Neptune up to 10 times the mass of our planet, orbiting hundreds of times further out than Neptune, with a year lasting potentially tens of thousands of Earth years. But prediction is one thing, finding it, that's another challenge entirely. The challenge, of course, is that objects so far away, barely warmed by our distant sun, are incredibly dim. They don't reflect much light, making them almost invisible to traditional telescopes. This is why the search has been so frustrating. It's like looking for a single unlit candle in a cavern the size of a galaxy. But modern astronomy has secret weapons. Infrared light. Everything that has any temperature at all emits infrared radiation, even an icy giant billions of miles from sun. And this is where the story takes its incredible turn. In 2025, a team of international astronomers meticulously combing through the archival data from the past infrared space telescopes like IRAS and Akari, AKARI, made a stunning announcement. They weren't just looking for the gravitational tugs anymore, they were seeing something moving. A subtle, incredibly slow moving trail of infrared radiation consistent with a massive object. Think of it like cosmic forensic investigation. IRAS launched in 1980 and Akarai launched in 2000s, captured snapshot of the entire sky. This team realized that by comparing images taken years apart, they could identify objects that had shifted their position ever so slightly against the fixed background of the stars. It was needle in a haystack, but they found it. The data, even from the decade old telescope, was compelling. The object detected had a brightness and movement pattern that strongly suggests a body about 5 to 10 times the mass of Earth, perfectly aligning with the predictions for the planet 9. It apparently, moving in one direction in one orbit, and the motion indicated an orbital path hundreds of astronomical units away from Sun, far beyond the Kuiper belt. This wasn't quick close-up detection. It was painstaking pixel by pixel comparison, cleaning up decades of noise, shifting through millions of data points. The team reported a direct hit, a consistent signature in multiple data set that even extrapolated matched the predicted location of planet 9. But even more exciting is how well this observed movement explains the gravitational anomalies we have been seeing. This newly identified object could be the very source of those mysterious tugs on the distant Kuiper Belt objects, finally providing an unified explanation for the decades of perplexing observations. It's a kind of moment that sends shivers down the astronomer's spine. So, if it is real, what is this massive something like? Current models suggest it would be a cold, dark world far too distant for liquid water to exist on its surface. It would likely have a thick atmosphere of hydrogen and helium, similar to our gas giants, but scaled down, a small mini Neptune or an ice giant. Its surface, if it even has one in the traditional sense, would be a frozen wasteland, possibly covered in exotic ice like methane, ammonia, and water ice, solidifying under immense pressure. The sunlight it receives would be hundreds or even thousands of times fainter than what we experience on Earth, a perpetual twilight, if not near darkness. The term super Earth sometimes implies a rocky world, but at this mass and distance, it's more likely to be a blend of rocky cores surrounded by an extensive icy mantle and thick gaseous envelope. It's completely different class of planet than anything else in our solar system, and even different from Jupiter, Saturn, Uranus, or Neptune. It's a true frontier world. Detecting a faint infrared signature is one thing, getting a direct, undeniable optical image is another, and this is where the future of astronomy truly shines. Enter the Vera C. Rubin Observatory in Chile. This revolutionary telescope, which recently became fully operational, isn't just big, it is designed to survey the entire visible sky every few nights. It's gigantic 8.4 meter mirror and 3.2 gigapixel camera will create the legacy survey of space and time, generating an unprecedented map of the universe. And it is perfect for Planet 9. If this distant world exists, and if the infrared data has given us an accurate enough prediction of its current position, the Rubin Observatory is powerful enough and sweeps the sky frequently enough to finally see it, to capture the actual reflected light from this massive hidden planet. The astronomical community is holding its breath. Over the next year, as Rubin begins its full operational survey, we could finally get our first direct glimpse, a photographic confirmation that would cement Planet 9's place in our solar system's history books. The confirmation of Planet 9 wouldn't just be another entry in any astronomy textbook. It would fundamentally rewrite our understanding of how our solar system formed and evolved. It could provide clues to the early chaos of the planetary migration, perhaps even suggesting that Planet 9 was once closer to Sun before being kicked out to its distant lonely orbit. It's also open to new avenues for planetary science, a whole new world unlike any other we have studied up close, waiting to be explored. And what unique geological processes occur on a planet so far from Sun? Could it harbor a subsurface ocean kept warm by the tidal forces from its own moon or by the internal radioactivity? The possibilities are endless. Imagine the future mission, a robotic probe launched decades from now, making an epic journey to study this new world up close. It's a testament to the enduring mysteries of the space and humanity's insatiable drive to explore. Our solar system just got a whole lot more interesting. We are on a precipice of one of the greatest astronomical discovery of our lifetime. The evidence is mounting, the telescopes are ready, and the universe is about to reveal another one of its profound secrets. So friends, what do you think? Is Planet 9 real? Will the Rubin Observatory be the one to finally capture its image? Let me know your comments below. And if you enjoyed this journey to the edge of our solar system, make sure that you hit that subscribe button, ring the notification bell so you don't miss out our next cosmic adventure. Stay curious and keep looking up. See you in the next one.